Voltmeter is a device used for measuring potential difference between the terminals of a component in an electric circuit. When a voltmeter is connected across the terminals of a component in parallel to it, the potential difference between the terminals of the component also appears across the voltmeter, which measures it. Suppose that we want to measure the potential difference between the ends of a resistance R carrying some current I in a circuit when a galvanometer of resistance G is connected across R. The total resistance of the circuit becomes R dash is equal to R1 plus R into G upon R plus G. This shows that the resistance of the circuit gets changed, and so the value of the current through R also changes. And in addition, some current flows through G. Thus the potential difference across R, which was earlier equal to IR, also gets modified. If the resistance G of the galvanometer is made very large in comparison with R, the effective resistance R dash can be written as, neglecting R in R plus G, we get R dash is equal to R1 plus RG upon G. That is equal to R1 plus R. Under this circumstance, the total resistance of the circuit does not change, and the resistance G being very high in comparison with R, almost all the current passes through R. So, the value of the potential drop IR across it also remains almost the same and is correctly measured. The discussion above shows that the device used for measuring voltages should have very large resistance of their own. In principle, infinite. Thus, to convert a galvanometer to a voltmeter, one connects a resistance of large value in series with it. Further, because of this large resistance, very little current flows through the galvanometer, so that there is no risk of damaging it. Calculating a series resistance appropriate to convert a galvanometer to a voltmeter. Consider a galvanometer with its resistance equal to G and a current Ig for its maximum deflection. One wants to convert it to a voltmeter to read a maximum voltage V. What should be the value of the series resistance to be used in the series with G? If the voltage difference between A and B in the circuit shown is V, then connecting the galvanometer and the resistance Rs in the series across A and B should give the current Ig through the galvanometer. Therefore, Ig into G plus Ig into Rs is equal to V. Therefore, Rs is equal to V upon Ig minus G. Connecting a resistance of this value in the series with the galvanometer will give a voltmeter, will give a full-scale deflection for a voltage V across its terminals. It can then be suitably calibrated.